Sorry for inconvenience. Good evening, students. Welcome to Sankalp Learning Solutions. In our last class, we were discussed about some concept related to light reflection and refraction. Okay, just analyze the concepts once. Okay, yesterday's class we were discussed about what is the definition of light, and then uh, after that we just discuss the concepts. What are the main uh, main phenomenon of lights? Okay, then after that we discussed about the reflection of plane mirrors, right? Reflection of plane mirrors, and then again uh, uh, types of mirrors, right? Types of mirrors, that is plane mirror and spherical mirrors. In that uh, we learned about the spherical mirrors also. Again, spherical mirrors are classified in two types. One is concave mirror and another one is convex mirror. One is concave mirror and another one is convex mirror, right? Okay. See, in that we just study that concept, that is rules, what we are going to apply for the reflection of spherical mirrors. Okay. So these all are the terms. Yesterday's class we just discussed about this, right? Center of curvature and radius of curvature, what is pole and all, right? I just show this diagram and explain all those things. Okay. Then this was also completed, that is reflection by spherical mirrors. Reflection by spherical mirrors. These are the rules we have to follow to form the reflection in spherical mirrors. Okay. Then see, until this is completed, right? Okay. Now now you have to learn about, you are going to study about the images formed by concave mirror. Image formed by concave mirror. See, student, see this diagram once. See this diagram once. See, which mirror this is? Which type of mirror is this? Which already two types of mirrors, right? One is concave mirror and another one is convex mirror. Okay. Of mirror is this. This is inward, right? This is bending inwards. So this is considered as concave mirror. Okay. Now, we will discuss about how the image is formed when the object is placed in the different places. Okay. When the object is placed in the different places, how the image is formed in concave mirrors. Say this diagram once. And, we will explain. Let we discuss this concept. Okay, so this diagram once carefully. See, this is concave mirror. This is inwards, right? Bend inwards, and then this surface is considered as not reflecting surface. This is only reflect surface. Okay. See, first one, here they place object is in infinite distance. What is infinite distance, students? What is infinite distance? Infinite is nothing but here the object is so far from this concave mirror. So far from concave mirror. Okay, here the object is so far. Object is placed in infinite distance. Then the light is fall on this object and then it reflects from this surface of concave mirror. The surface of concave mirror, and then again it gets reflected and it passes through this point, right? It passes through this point. This point is considered as, what is F here? In our yesterday's class, we have learned about these terms and all, right? This is also one of the terms used in a mirror. Here F is nothing but principal focus, right? F is nothing but principal focus. So all the reflected ray get uh, get converges in the point, that is F. Okay. See, just understood this statement. When the object is infinite, the image is formed at the focus. Okay, see, all the reflected rays are converges in this point F, and again the image is also formed in this point. Image is also formed in this point. When the object is in infinite distance, the image is formed in principal focus point. Then, but how is the image is formed here? What are the characteristic of that image form here? See, this is the image is highly diminished and re-image is formed here. We all know that, right? We all are well known about the types of image formation, whether it is in real or virtual images, right? In my yesterday's class, I already explained, right? I have already explained about uh, real and virtual images. In which type of image formed? Real image is formed. Then it is also inverted. Inverted means what? Inverted means like this. This is object and this is image. Okay. See, first characteristic is here image is formed in the point F when the object is in infinite distance. In concave mirror, when the object is in infinite distance, the image is formed in principal focus, that is the point F. And how was that image? It is look like highly diminished, real, and inverted images formed here. And this is the one condition. This is one example when object is infinite. Okay. Next, second one, here this time the object is placed beyond C. Object is placed beyond C. See students, just observe this image. See, this is point C and this is F and this one is 4P. Here object is placed beyond the point C. Object is placed beyond the point C. See, this is the object. Then what's formed here? The image is formed between C and F. C is nothing but center and F is principal focus. The image is formed in between the C and F point. See, here the image is formed, right? Observe this diagram. See, how is this image? What's the of this image? Firstly, it's inverted, right? It is inverted and then diminished and real image is formed here. Students, we know that real image is nothing but we can record this image in screen, right? So see this, we can see this image, right? So it's real image and again it is inverted and diminished. When the object is in beyond C, the image is formed in between C and F points and the image is real, inverted and again it is diminished image. Okay. Next one. Here the see read the statement object is at C. This time they place the object in a point C. Okay, C is nothing but consider it as center, right? Okay. See, this time they place the object in C point. Then again, this is incident and it get reflected from this surface and again this is the reflected ray. It passes through the point F. Okay. This time the image is formed at the same point where the object is placed. Firstly, they place the object in the point C, right? Again, then after reflection, the image is still formed here at the same point C. But how the images look like here? What are the characteristic of this image? See, this is firstly inverted. Tale ಕೆಳಗಾಗಿದೆ ಅಲ್ವಾ? So this is inverted. And again, we can record this image in the screen, right? We can record this image on screen. So this is called real image. And then the size is equal, right? Here both the object and image size are equal. Okay. See, this is third place when the object is at C point. I think you all are understood this concept, right? So it's very simple. When I explain this, when I was explained, I think uh, you all are listen it carefully, right? Okay. Then again, next place, that is fourth one. When this time where the object is placed, the object is between C and F. See this is C point and this is F point. Here, this time the object is placed in between C and F. This time the object is placed in between C and F. See, this is the object. Okay. Again, the light is incident on the surface. Uh, Remember, this is which type of mirror? It is concave mirror because it bend inwards. Okay. So this is considered as in reflect surface. So since it is on the surface, uh, get reflect from this surface and passes through the point F. But where the image is formed here, when the object is placed in between C and F, the image is formed beyond C. The image is formed beyond C. ಹೌದಲ್ವಾ? C point ಗಿಂತ ಹಿಂದೆ ಏನಾಗಿದೆ? Image form ಆಗಿದೆ. Okay. Image characteristic and how this image look like. See, it is firstly enlarged image. Enlarged is nothing but it is actually big size as compared to this object size. Okay. Then it is second point, it is real image. And again, here the image is inverted. Again, image is inverted. Okay. This is the fourth point. Next one, this time the object is at the point F. Where the object is at the point F. It is nothing but principal focus, what we call. Okay. Okay. See, this is the object placed in the point F. Where the image is formed? Image is formed at infinity. Infinity means so far. Okay. We can't see here the image formation. So it's infinity. So that's why we show the point like this direction. Okay, somewhere here or what, somewhere place the image is formed here. So for image is formed at infinity. It is how images look like? It look like highly enlarged, real, and again inverted images formed. Okay, students, in all points, one common thing is there. What is that? Always here, when we consider this concave mirror, the image is always real and almost all the time the images look like inverted images. Okay, let us move next. When an object, this time the object is between F and P. The object is between F and P. See this image carefully. See this diagram carefully. Here, the object is between this point F and P. P is nothing but pole. F is principal focus. Object is here. See, this is in between F and P. Now, the image is formed here. Okay, the image is formed beyond the screen. See, screen is here, but the image is formed beyond the screen. Howdalva? ಪರದೆಯ ಹಿಂದ್ಗಡೆ ಏನಾಗ್ತಾ ಇದೆ, ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗಿದೆ. ಇಮೇಜ್ ಹೇಗ್ ಕಾಣಿಸ್ತಾ ಇದೆ? ಹೌ ಇಟ್ ಲುಕ್ ಲೈಕ್? ಇಟ್ ಲುಕ್ ಲೈಕ್ ಇಟ್ ಈಸ್ ಎನ್ಲಾರ್ಜ್ಡ್, ಬಟ್ ದಿಸ್ ಟೈಮ್ ವರ್ಚುವಲ್ ಇಮೇಜ್ ಈಸ್ ಫಾರ್ಮ್ಡ್. ಓಕೆ, ನಾನು ಹಿಂದೆ ಎಲ್ಲ ಹೇಳಿದೆ ಅಲ್ವಾ, ಆಲ್ಮೋಸ್ಟ್ ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅಲ್ಲಿ ರಿಯಲ್ ಇಮೇಜಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅಂತ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗಿದೆ, ವರ್ಚುವಲ್ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗಿದೆ. ಇದನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಸ್ಟೂಡೆಂಟ್ಸ್. ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಕೇರ್ಫುಲ್. ಓಕೆ, ಕಾನ್ಸಂಟ್ರೇಟ್ ಇಟ್. ಓಕೆ, when the, ಯಾವಾಗ ವರ್ಚುವಲ್ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗಿದೆ? when the object is placed in between f and p. when the object is in between f and p, the image is formed beyond the screen. And what are the characteristic of that image? It is firstly enlarged, and secondly it is virtual, and erect image is formed. Okay, see, oh, these all are the image formation in concave mirrors. Yes, I think you all are ನಿಮ್ಗೆ ಎಲ್ಲರಿಗೂ ಈಗ ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಅನ್ಕೊಳ್ತೇನೆ. ಅಂಡರ್ಸ್ಟುಡ್ ನಾಟ್? See, next one, image is formed by convex mirror. Again, here we take second type of spherical mirror, that is convex mirror. See, this is image of convex mirror. Here it bent outwards, right? It bent outwards. Firstly, here they placed the object where the object is placed when the object is at infinite. This time the object is placed in infinite distance, right? Okay, where the image is formed, and what are the characteristic of that formed image here? See, the image is formed at f. Where the image is formed here? Here the image is formed in the point f. This is the f point. Here the image is formed. So this is behind the mirror. Okay, this is behind the mirror. It is then what are the characteristic of that image? How it look like? See, it is highly diminished, and virtual image is formed here because this is behind the mirror. So it is virtual always, and erect image is formed. Okay, this is first point. And second one, an object is between infinite, or we can call like this, also it is beyond the point P. Okay, the how image is formed? Image is formed behind the mirror. Here also, sorry, this time image is formed here. And how it look like? It is diminished, virtual and erect images formed. Okay, next, see, these all are the concept related to the image formation in concave and convex mirror. Let us move next one. So this is so easy concept, uses of spherical mirrors. This is also one of the important, because in exams they ask to write the uses of spherical mirrors, whether it may be they ask about concave mirrors or about convex mirrors. Okay, let's see one by one. First one, uses of concave mirrors. First one, uses of concave mirrors. ಇಲ್ಲಿ ನಾವು ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೇವೆ. ಸಿ, ಫಸ್ಟ್ಲಿ ವಿ ಯೂಸ್ in torches. Okay, we used in torches. See this image. This is the torch. This is the glass portion, right? Here, which type of mirror is used? Concave mirror is used. And next, it is used searchlights. See this. This is the searchlight. Where we use the searchlights? Almost all the time in orchestra programs, right? You all are, I think, well known about the some orchestra programs. Okay, singing competitions or orchestra programs. In that, they use the searchlights, and in that searchlight, which type of mirror is used? Concave mirrors are used. And again, it is used in headlights of vehicles. So in headlights of vehicles, which type of mirror is used? Concave mirrors are used. gives parallel beam of light. Okay. Next, again, it is used in shaving mirrors. Say this. It is used in shaving mirrors. Why? Why? Because it gives the larger image of the face. It gives the larger image of the face. That's why we use it in shaving mirrors. Next benefit or next use of this concave mirror is dentists. Dentists are used this type of mirror because they can see the larger image of your teeth by using this type of mirror. Okay. Next one, concave mirrors are used to concentrate sunlight to produce the heat in solar devices. Okay. See this in solar devices also use the concave mirrors. Why here they here use the concave mirrors? Because it concentrates sunlight in one point. We already learned about this, right? We always said like that the concave mirror always converges the light rays. It converges the light rays, means it is nothing but it concentrates all the light rays in one particular point. Okay, so that's why here we use the uh, so concave mirrors in solar furnaces. These all are the uses of concave mirrors. Okay, let us see the use of convex mirror. See this. Convex mirrors are used as rear view mirrors in vehicles. It is used as rear view mirrors in vehicles. See this image. This is the front mirror in vehicles, right? So, which type of mirrors are used here? Here we use the convex mirrors. Why we use the convex mirrors? Because it gives in rear view in vehicles. Okay. See, convex mirrors give erect diminished images of the object. We already uh, learned about this concept, right? Convex mirrors give erect, diminished images of the object. They also have wider field of view. This is important. See, this gives the wide field of view than plane mirrors. That's why we prefer here which type of mirror? Convex mirrors. Okay. These all are the uses of convex mirrors. Let us see the next concept, very important concept, that is Cartesian sign convention for spherical mirrors, or simply sign convention for spherical mirrors. Okay. We will uh, we have to study this concept. Okay. See, it's very important because they ask the problems related to this sign convention in spherical mirrors. Okay, so listen it carefully and I understood this concept. Okay. One, the object is always placed on the left of the mirror. See here, uh, whether it is concave mirror or convex mirror, some rules are common for both the mirrors. Okay. First, here the object is always placed on the which side of the mirror, or always left side of the mirror. Object is placed left side. See, this is object, right? It is placed in left side of mirror. Okay, left side of this mirror. So this is the first uh, remember remembering thing. Okay. Next, and light from the object falls from the left to the right. Why? Because the object is placed in left side. So the light is also falls from this object from left to right. Okay, this falls here and moving towards left, moving towards right. So first thing is always object is placed in left side of mirror. It may be concave mirror or we can take the convex mirror, but this object place is fixed, that is left side of the mirror. Okay. Let us see the second point. All distances parallel to principal axis. All the distances are parallel to this principal axis. This one are measured from the pole. Here we always measure it from the pole place. We know that this is the pole point, right? This is the pole point. Always all this are measured from this point only. That is principal. That is pole. Okay. Next, all this measure to the right of the pole. See, read the statement carefully and listen it also. Okay. All distances measured to the right of the pole. See this, all the distances are always measured from right side of this pole. See, this is the right side. Okay, this is left. Okay, are taken as which sign? Are taken as positive signs. All distances measured to the right of the pole are taken as positive. See this distance towards the right, it is considered as positive. It is considered as positive. So next one, all the distances measured to the left of the pole. This is left side of the pole. This is taken as negative. See this distance towards the left. This is taken as negative sign. Okay. Next, the height measured upwards perpendicular to this principal axis is taken as positive. See, this is object. It is placed from left side of this mirror and its distance is measured from this pole point. Okay, pole point to this object point. See, its height is always upwards. So, it is considered as positive. Which is taken as positive here? Object height is taken as positive. Okay. Then image is formed here. See this. This is the image formed here. So here the height is shown downwards. See students, ನಾನಿಲ್ಲಿ ಇಮೇಜ್ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ಅನ್ನ ಹೇಳ್ತಾ ಇದ್ದೇನೆ. ಸೊ ಇಲ್ಲಿ ಹೈಟ್ ಏನ್ ಮಾಡಿದ್ದಾರೆ, ಡೌನ್ವರ್ಡ್ ಅಲ್ಲಿ ತೋರಿಸಿದ್ದಾರೆ. ದಟ್ಸ್ ವೈ ವಿ ಟೇಕನ್ ಇಟ್ ಆಸ್ ನೆಗೆಟಿವ್. ದಿ ಹೈಟ್ ಆಫ್ ದ ಇಮೇಜ್ ಈಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ನೆಗೆಟಿವ್. ಓಕೆ. See this, the height measured downwards is perpendicular to this axis. See, this is the principal axis. This is the image formed here. It is exactly perpendicular to this principal axis. We can show like this. This is perpendicular or this is also perpendicular, right? So, see, here also this image formed is exactly perpendicular to this principal axis. And again, the height is considered, height of this image is considered as or taken as negative. Height is taken as negative here. Okay. See. Height is considered as negative. These all are the important concept which we are going to remember. Okay. See, this sign convention is very, very important. So, remember these all things. I will repeat it once. Listen carefully. First thing is, when here the object is always placed left side of the mirror, whether it may be concave mirror or convex mirror, the rule is same. Okay. Here the object is always placed left side. Then second rule is what? Always measure distance and image distance and object distance is this reference point, that is pole. Okay, this is the second point. And next one, if suppose all distances measured to the left of the pole, that is taken as negative. Left of the pole is taken as negative, and if it's right side, then it is taken as positive. Okay. Next thing is The height measured upwards, which is perpendicular to principal axis, taken as positive. ಇಲ್ಲಿ ಯಾವ height ಅನ್ನ ತಗೊಂಡಿದ್ದಾರೆ? They consider here height of the object, right? Object height is considered as positive, and again the height of the image is downward, so it's consider it as negative. Okay, it is negative. So these all are the very, very important concept. So remember it carefully. Okay, let us see next. Depending upon this, next they explain some formulas related to spherical mirrors. These all are the common formulas for uh, two types of spherical mirrors. Only little bit difference is there. Okay, see what are those? First formula, mirror formula for spherical mirrors. So this is the common formula for spherical mirror, concave and convex. Say this. The mirror formula for spherical mirrors is, this formula tells about the relationship between what and what? The relationship between object distance, that is considered as u, object distance, and second thing is image distance, that is v. Second thing, image distance, that is v. First one is object distance u, and second one is image distance v. So this mirror formula gives the relation between object distance and image distance. Okay, see, and again about the focal length. We know that focal length is denoted by the letter small f, right? Focal length is denoted by the letter f here. So then what is the formula? What is the formula? See, 1 by v plus 1 by u is equal to 1 by f. This is the formula. 1 by v. What is v here? V is image distance. It is image distance. And again, 1 by v plus 1 by u. U is nothing but it is, sorry, here v is image distance and u is object distance. Okay, object distance. 1 by v plus 1 by u is equal to 1 by f. This is the formula for uh, spherical mirror. Okay, next, this is called mirror formula for spherical mirrors. So remember it. It's very, very important. Again, they ask some problems related to this formula. Okay, that time you only remember what is u, what is v, what is u, and what is f here, and what is the formula to substitute to solve those problems. Okay, so that's why I'm telling these formulas are very, very important. Each and everything comes, this formula is also important. Okay, next one, magnification for spherical mirrors. Say, what is magnification for spherical mirror? Magnification for spherical mirrors is the ratio of height of image to the height of the object. This magnification is also here again one of the formula comes. Okay, what is that? Magnification formula. What it tells, it gives the relationship between height of the image and height of the object. Okay, see, magnification is equal to height of the image divided by height of the object. Again, they give it as, or we can write like this also. Here m is magnification and hi is height image and h naught is the height of object. Okay, this is the formula to calculate magnification for spherical mirrors. This is the common formula. Okay, then ನಾನು ಆಗ್ಲೇ ಹೇಳಿದೆ ಈ ಎರಡು ಫಾರ್ಮುಲಾನು ಕಾಮನ್ ಇರುತ್ತೆ. For what? For concave mirror and convex mirror. But only the thing changes here is sign convention. Okay. Sign convention ಮಾತ್ರ change ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ ಹೇಗೆ change ಆಗುತ್ತೆ? See, the magnet is also related to object distance and image distance. Here two things you have to remember. One is magnification related to height of the image and height of the object. Again, it is related to object distance and image distance. Then how can we write this formula related to height? See, related to distance, height, we can write like this. Okay, m is equal to h I divided by h naught. Okay. See, magnification is also related to object distance and image distance. How we represent? See, magnification m is equal to V by U. Here they mention minus. Okay, this depending upon which type of mirror we considered here. Okay, ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ನೆಗೆಟಿವ್ ಅನ್ನೋದು ನಾವು ಯಾವ ಟೈಪ್ ಮಿರರ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೇವೆ ಅನ್ನೋದ್ ಮೇಲೂ ಬರುತ್ತೆ. ಹಾಗೆ ನಾವು ಈಗಷ್ಟೇ ಕಾರ್ಟೀಷಿಯನ್ ರೂಲ್ಸ್ ಅನ್ನ ನೋಡಿದ್ದೇವೆ ಅಲ್ವಾ, ಅಲ್ಲೂ ಕೂಡ ಇತ್ತು ಆಬ್ಜೆಕ್ಟ್ ಏನ್ ಮಾಡ್ತೇವೆ ನಾವು ಇಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ನೆಗೆಟಿವ್ ಅನ್ನ ಹಾಕ್ತೇವೆ. ಸೊ ಅಲ್ಲಿ ರೂಲ್ ಅಲ್ಲಿ ಈಗ ಆಲ್ರೆಡಿ ನಾವು studied this all things. Okay, just remember that and put this sign. Okay, see, this all about mirror formula and magnification formula for spherical mirrors. Understood or not? ಓಕೆ, ನಂಗೆ ನೀವೆಲ್ಲ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀರಾ ಅಂತ ಅನ್ಕೊಳ್ತೇನೆ ಅಲ್ವಾ ವಿದ್ಯಾರ್ಥಿಗಳೇ? ಓಕೆ ಸ್ಟೂಡೆಂಟ್, ನೆಕ್ಸ್ಟ್ ವಿ ಸಿ ಅಬೌಟ್ one of important phenomena of light. We already learned about 4 types of phenomena, right? ಈ ಚಾಪ್ಟರ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲೇ ನಾನು 4 types phenomena ಬಗ್ಗೆ ಇಮೇಜ್ ಅನ್ನ ತೋರಿಸಿ ಹೇಳಿದ್ದೇನೆ ಅಲ್ವಾ. ಅದರಲ್ಲಿ one is reflection of light and another second one is refraction of light and third one is dispersion of light and fourth one is scattering of light. Dispersion ಮತ್ತೆ scattering ಬಗ್ಗೆ ನಿಮಗೆ ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. That time we will discuss about those characteristics or those phenomena of light. Okay, see, now we are going to discuss about refraction of light. Then what is refraction of light? See, we already know that light is always travels through straight line, right? Light is always travels through straight line. At that time, the reflection is occurred. That reflection concept, we just consider same medium. Okay, just consider same medium. When the light is incident on one medium and reflected back to that same medium. Okay, so here what happens in refraction? Here we consider mainly types of mediums. See, what is the statement tells? When transparent medium into another transparent medium, it gets bent. What happens here? When the light is incident one medium and it gets refracted through second medium. Okay, that's why mainly here we consider two types of mediums. Okay, this is the definition of refraction of light. What is the definition tells? When the light travels from one transparent medium to another transparent medium, it gets bent. When it passes from one medium to another medium, when it enters second medium, it gets bent. So that phenomena is called refraction of light. Okay, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಲೈಟ್ ಒನ್ ಮೀಡಿಯಂ ಇಂದ ಇನ್ನೊಂದು ಮೀಡಿಯಂಗೆ ಪಾಸ್ ಆಗುವಾಗ ಅನದರ್ ಮೀಡಿಯಂ ಸೆಕೆಂಡ್ ಪಾಸ್ ಆಗುತ್ತೆ ಅಲ್ವಾ, ಆಗ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಲೈಟ್ ಡೈರೆಕ್ಷನ್ ನಲ್ಲಿ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಇಟ್ ಗೆಟ್ ಬೆಂಟ್. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ರಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್. ಸಿ ಹಿಯರ್, ದಿಸ್ light is called refraction of light when light travels from a rarer medium to a denser medium. I firstly told this, right? When here we consider mainly two types of mediums. So whether it may be rarer medium and denser medium or vice versa. First medium is denser, second medium is rarer. Okay, this time we consider one is rarer medium and another one is denser medium. It bends towards normal. Here we consider one normal in between these two mediums. Okay. Here we draw one normal. Okay. ಈಗ ನಾನು statement meaning ಅನ್ನ ಹೇಳಿದ್ದೇನೆ. Now we will see what is the actual meaning of the refraction of light with the help of these images. Okay. See, travels from a denser medium to rarer medium or to rarer to denser, it bends. So once it bends towards and once it bends away from the normal. It depends upon medium. Okay. ಯಾವಾಗ ಅದು bend towards the normal ಆಗುತ್ತೆ and when it bends towards away from normal ಆಗುತ್ತೆ ಅನ್ನೋದು it purely depends upon ಅದು rarer to denser ಬರ್ತಾ ಇದೆಯೋ ಅಥವಾ denser to rarer refraction ಆಗ್ತಾ ಇದೆಯೋ ಅನ್ನೋದ್ರ ಮೇಲೆ ಏನಾಗುತ್ತೆ it depends. Okay. This is considered as normal. This is incident ray and it incident here and it comes from the rarer medium or it incident from rarer medium and this point is considered as point of incidence. ಹೌದಾ, ನಾವಿದನ್ನ ಆಲ್ರೆಡಿ ಎಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದ್ದೇವೆ ಅಂದ್ರೆ ಪ್ಲೇನ್ ಮಿರರ್ಸ್ ಅಲ್ಲಿ ರಿಫ್ಲೆಕ್ಷನ್ ಹೇಗಾಗತ್ತೆ ಅನ್ನೋದನ್ನ ಸ್ಟಡಿ ಮಾಡುವಾಗ ಅಥವಾ ಮಿರರ್ಸ್ ಅಲ್ಲಿ ರಿಫ್ಲೆಕ್ಷನ್ ಹೇಗಾಗತ್ತೆ ಅನ್ನೋದನ್ನ ಸ್ಟಡಿ ಮಾಡುವಾಗ ಈ ಪಾಯಿಂಟ್ ಬಗ್ಗೆ ಈ ನಾರ್ಮಲ್ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡಿದ್ದೇವೆ ಅಲ್ವಾ. ಸೊ ಹಿಯರ್ ದಿಸ್ ಇಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ನಾರ್ಮಲ್ ವಿಚ್ ವಿ ಡ್ರಾನ್ ಬಿಟ್ವೀನ್ ದಿಸ್ ಇನ್ಸಿಡೆಂಟ್ ಅಂಡ್ refracted rays. So this is incident ray when it is incident from rarer medium, denser medium. Once it passes from rarer medium to denser medium, what happens? See, it get reflected like this. Okay, see this line. See this line. They get bent towards this normal. They get bent here and it is towards the normal. See this ray. Okay, this is refracted ray. It get bent towards the normal. It get bent towards the normal. Okay. See, this is one type. When the light is refracted from rarer to denser medium, this is the image. And second one, when it passes from denser to rarer. Okay. See this is normal. Again, here light is incident here, this point from denser medium and it passes from denser to rarer medium. This time this medium is reverse. Okay, here rarer to denser, here denser to rarer. This time what happens? This refracted ray moving away from this normal. Okay, or bent away from this normal. See this is away. ದೂರ ಹೋಗ್ತಾ ಇದೆ. See here, this is bent towards. ಇಲ್ಲಿ ನಾರ್ಮಲಿಗೆ ನಾರ್ಮಲ್ ಹತ್ರನೇ ಬೆಂಡ್ ಆಗ್ತಾ ಇದೆ. That is the difference. Okay. See this. Again, they explain the refraction of light through a rectangular glass slab. So here they consider one glass. Okay, here one glass is considered as one medium and air is considered as another medium. What happens here? See, again here refraction takes place from air medium to glass medium. Okay, at that time what happens? See this diagram. This is considered as incident ray. Here they mentioned. Okay, this ray is incident ray and this is called angle of incidence and this is the angle of refraction. This is considered as normal and this is refraction. Okay, refraction occur. This is called refracted ray. Okay, this is called refracted ray. Again here normal is formed and again it bent. Okay, this is considered as emergent ray. See this emergent, when a ray of light passes through a rectangular glass slab. ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ದಾರೆ, ಒಂದು ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ ಅನ್ನ ಇಟ್ಟಿದ್ದಾರೆ. ಲೈಟ್ ಏನಾಗ್ತಾ ಇದೆ, ಏರ್ ಮೀಡಿಯಂ ಇಂದ ಈ ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬಿಗೆ ಬರ್ತಾ ಇದೆ. ಈ ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ ಅನ್ನ ನಾವು ಗ್ಲಾಸ್ ಮೀಡಿಯಂ ಅಂತ ಹೇಳ್ತೇವೆ. ಓಕೆ, ಸಿ ದ ಲೈಟ್ ಈಸ್ ಕಮ್ ಫ್ರಮ್ one medium, that is air, and it get refracted through glass medium. Glass medium is considered as second medium. So one is rarer and another one is denser. Okay, what happens here? It gets twice. See, ಕ್ವಶನ್ ಬರುತ್ತೆ ಅಲ್ವಾ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಟ್ ಹೇಳಿದೆ ಟ್ವೈಸ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ನಮ್ಗೆ ಇಲ್ಲಿ ಒಂದ್ ಸಲ ಬೆಂಡ್ ಆದಾಗೆ ಕಾಣಿಸ್ತಾ ಇದೆ. ಸಿ when incident here from air medium to glass, what happens? It gets reflected through this glass medium. So it gains towards this normal. Okay, it gets towards this normal, and again second time this light comes out. How? Again this light passes from glass medium to air medium. First time air to glass bandide, second time glass medium inda air medium ಗೆ ಪಾಸ್ ಆಗ್ತಾ ಇದೆ. ಇಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಅನ್ನ ನೋಡಿ. This is normal. Here again refracted from glass to air medium. This time this light bent away from this normal. See, this time it went away from this normal. Okay, that's they mentioned here, bent twice. One time it bent here, and second time this. See, this is the first bent and this is the second bent. Okay, this is the meaning of the statement. The ray, this is called, see this. This is called incident and this is called refracted ray, and this outcome ray is called emergent ray. So the emergent ray is parallel to the incident ray. This emergent ray is parallel to this incident ray. Parallel ಅನ್ನ ನಾವು ಹೀಗೆ ತೋರಿಸ್ತೇವೆ ಅಲ್ವಾ, or ಹೇಗೆ ತೋರಿಸ್ತೀರಾ ನೀವು? ಪ್ಯಾರಲಲ್ ಅಂತ ತೋರಿಸ್ತೇವೆ ಅಲ್ವಾ, ಅಥವಾ ಹೀಗಾದ್ರೂ ಇರ್ಬೋದು. ಸೊ ಇಲ್ಲಿ ಹೇಗಿದೆ? ಹೀಗಿದೆ ಅಲ್ವಾ. Here this emergent ray is this one. This emergent ray is parallel to this incident ray. This is the meaning. Clear ಆಯ್ತು ಅಲ್ವಾ ಈ ಕಾನ್ಸೆಪ್ಟ್? Okay, next one again wrote some laws of refraction of light. ಪ್ರೀವಿಯಸ್ಲಿ ನಾವು ಸ್ಟಡಿ ಮಾಡಿ ಬಂದಿದ್ದೇವೆ ಲಾಸ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಷನ್ ಆಫ್ ಲೈಟ್. ಹೌದಾ? ಹಾಗೆ ಇಲ್ಲೂ ಕೂಡ ರಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್ ಗೆ there are two important laws. What are those? One is here the incident ray and the refracted ray and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. See, this is the simple statement. What are the concepts are lie in the same plane here? First thing, the incident ray, and second thing, the normal which we drawn at that point of incidence, and next one is refracted ray. All are lie in the same plane. This is the first law of refraction of light. This is the first law of refraction of light. What second law tells? The ratio of sine of angle of incidence to the sine of angle of refraction is constant. Here ratio of sine of angle of incidence is equal to sine of angle of refraction anta helteve. We know that sine angle, cos angle, tan angle and all. Okay, you have already learned this concept in maths. Yes or no? Yes, these concepts comes in maths. Okay, so here we consider sine angle. ಇಲ್ಲಿ ಯಾವ್ಯಾವ್ದು equal ಇರ್ಬೇಕಂತೆ? Sine I is equal to sine R. Okay, this is the ratio of sine I divided by sine R. This is the very important concept. This is called Snell's law of refraction. Sometimes in your exam they ask, write the Snell's law of refraction with the statement and its formula. Okay, At that time, what you write? Snell's law tells that it gives the ratio of sine of angle of incidence to the sine of angle of refraction. Sine I divided by sine R is equal to constant. This is the Snell's law of refraction. Okay, next one. This concept is very simple. Okay, next one, refractive index. What is refractive index? Refractive index is nothing but, see here, the absolute refractive index of a medium is the ratio of speed of light in air or vacuum to speed of light in medium. Again, here we consider two types of mediums. Okay, refractive ಅಂದ್ರೆ ಏನು? It is ratio of speed of light in air or vacuum to speed of light in medium. Speed of light in air or vacuum to speed of light medium. ಅದನ್ನ ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ದೇವೆ? notation ಅನ್ನ ಯೂಸ್ ಮಾಡಿ ಬರ್ದಿದ್ದೇವೆ. Speed of light in air is denoted by C and speed of light in medium is denoted by V. So refractive index is the ratio of speed of light in air to speed of light in medium. This is called refractive index. See, again, here they consider some medium is considered as medium 1 and another one is considered as medium 2. Okay. This time the formula becomes N21, means 2 is the second medium, 1 is first medium. Here the refractive index of a medium 2 with respect to a medium 1 is the ratio of speed of light in medium 1 to the speed of light medium 2. So N21 is equal to V1 by index when we consider two different mediums. Okay, let us see next concept. Next one is spherical lenses. See, firstly we already learned about concept of mirrors, right? Spherical mirrors. This one is spherical lens. Don't get confused. Okay, read those statement clearly in your exams and then answered it. First, so here spherical lenses. A spherical lens is a transparent material. Say this, here the spherical lens is a transparent material bounded by two surfaces. What is the difference between the mirror and lens? In the mirrors, it bends only one surface, but in lens, it bends in two surfaces. See, this is the image. One is concave mirror and another one is convex mirror. Okay, one is concave and another one is convex mirror. Here, the surfaces are bent in two surface. Okay, here the lens are bent in two surfaces. Spherical are of two main types. The first one is convex and another one is concave lenses. Same mirror ಅಲ್ಲಿ ಹೇಗೆ concave mirror, convex mirror ಅಂತ ಹೇಳ್ತೇವೋ ಇಲ್ಲೂ ಕೂಡ concave lens and convex lens ಅಂತ ತಗೊಳ್ತೇವೆ ಆಯ್ತಾ. So what is concave lens? Say this. This is thinner in the middle and thicker at the edges. This is thinner in middle and thicker at the edges. Refer this diagrams. So one is concave lens and another one is convex lens. Okay. See here. This image is related to second explanation, that is concave, and this is related to convex lens. Okay, in convex lens is thicker in the middle and thinner at the edges. Rays of light parallel to the, what happens here? Here the rays of light are parallel to the principal axis, after refraction through a convex lens meet at a point. It meets at a point, or what we call converge at a point. See this, converge at a point on the principal axis. It converge at a point on the principal axis. These two are the diagrams. Here they explain both concave and convex mirrors. Concave and convex mirrors. See, explanation related to concave mirror is thin in the middle and thicker at the edges. It is thinner in middle and thicker at the edges. Rays of light parallel to principal axis. Again here the rays of light are parallel to the this principal axis. Okay. After refraction, get diverged and appear it look like come from O from at a point on the principal axis on the same side of the lens. See this. Here these all incident rays are parallel to the this principal axis and all are get diverged here. Okay, get diverged here. This all are the concept related to convex lens and concave lenses. Next one, how the refraction takes place by spherical lenses. How the refraction takes place in convex lens and concave lens. Let us see. First one, in a convex lens, a ray of light parallel to the principal axis. In a convex lens, a ray of light is parallel to the principal axis. ಈಗಷ್ಟೇ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ ಅಲ್ವಾ? ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಇಂದ ಬರ್ತಾ ಇರೋ ರೇ ಆರ್ ಇನ್ಸಿಡೆಂಟ್ ರೇ ಯಾವುದಕ್ಕೆ ಪ್ಯಾರಲಲ್ ಆಗಿರುತ್ತೆ, ಪ್ರಿನ್ಸಿಪಲ್ ಆಕ್ಸಿಸ್ ಗೆ ಪ್ಯಾರಲಲ್ ಆಗಿರುತ್ತೆ. ಆಫ್ಟರ್ ರಿಫ್ರಾಕ್ಷನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಇಟ್ ಪಾಸಸ್ ಥ್ರೂ ದ focus. After refraction, what happens here? It passes through the focus. Commonly ಬರ್ದಿದ್ದಾರೆ for concave and convex lenses. See here, it passes through here. Okay, focus on the other side of the lens, and in concave lens, it appears to diverge from the focus. In a concave lens, okay, a concave lens, it appears to diverge from the focus. ಇದು focus ಇಂದ diverge ಆದ ಹಾಗೆ ಕಾಣಿಸ್ತಾ ಇದೆ. On the same side of the lens, it is diverge, and in convex, it gets converge. Okay, it gets converge. So this is the first rule. And second one, in a convex lens, a ray of light passing through the focus after refraction. Before refraction, it passing through the focus. Okay, this incident ray passing through the focus here. See this one, and goes parallel to the principal axis. This is principal axis. It is parallel to this principal axis. This one is parallel to principal axis. In a concave lens, a ray of light directed towards the focus. It is directed towards the focus. After refraction, goes parallel to principal axis. After refraction, both cases, it goes parallel to. In a concave lens, it goes parallel to principal axis. This is the second rule. And next one, in a convex lens and concave lens, a ray of light passes through the optical center. Say this is considered as optical centers, denoted by the letter O, right? Goes without any deviation. Here it comes here and passes through this point and get refracted. It's very, very simple. Okay. So these all are the concept. These all are the concept related. These all are the concept related to the image formation or refraction, loss of refraction related to the lenses. Okay, loss of refraction related to lenses. Okay, students. Okay, students. Today's class. Now just analyze the concept. Okay, what we have studied in our today's class. Okay, firstly, we learned about the mirrors. Okay, we learned about mirrors, concave and convex mirrors, then rules to form the reflection in these two types of mirrors, concave and convex mirrors. And later we just learned the concept. What is that? In the different places, when object is placed, and the object is placed in different places, the image is formed. That's also studied. Okay, that's also we already learned. Okay, next, what is the concept? Next one is mm, very, very important phenomena, that is refraction of light. How the refraction takes place in light. Here we consider two different mediums, first medium and second medium, whether it may be rarer or denser rarer, how the refraction takes place in two different mediums. We learned this concept with the help of uh, refraction takes place in rectangular glass slabs. ಹೌದಾ? Rectangular ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿ ಏನ್ ಮಾಡಿದ್ದೇವೆ, ಇದರ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡಿದ್ದೇವೆ. ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಇಸ್ ಮಿರರ್ ಫಾರ್ಮುಲಾ ಫಾರ್ concave and convex mirrors, and then magnification formula for two types of mirrors. And then next very, very important concept is about the lenses. Okay, what are the concave lens and convex lenses, how the image is formed, or what are the normal concept when we are going to draw the images in concave lens and convex lenses. So idishtana ಏನ್ ಮಾಡಿದ್ದೇವೆ, we learnt all these concepts in today's class. So we will meet in the next session, that is last session of this light chapter. So please attend ಸೆಷನ್. ಓಕೆ, ಸೊ ಅದನ್ನ ನೀವು ಅಟೆಂಡ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಅಲ್ಲಿ ಕೆಲವೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ಮಿಸ್ ಆಗತ್ತೆ. ಸೊ ನಮ್ಗೆ ಅದ್ರ ಮೂಲಕ ನೆಕ್ಸ್ಟ್ ಅಲ್ಲಿ ಕೆಲವೊಂದು ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ಸೊ ಐ ವಿಲ್ ಟ್ರೈ ಟು ಸಾಲ್ವ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ನ್ಯೂಮೆರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆಲ್ಸೋ ಇನ್ ಲಾಸ್ಟ್ ಸೆಷನ್. ಸೊ ಟ್ರೈ ಟು maximally try to attend the session. Okay, okay, students. Bye. Take care.